In this lesson, we're going to look at a method for finding the summation of a series called the method of differences. Now, this method can only be applied in very specific situations, so we're going to look at what a summation would need to look like in order for this method to be applied, and then how to use the method. So we're going to start by expanding this summation, but we're not going to simplify the terms. We're going to see what happens when we leave it in its expanded form. So the rule is r plus 1 times r plus 3 minus r times r plus 2. We want to find the sum of all the terms starting with r equals 1 and ending with r equals n. So we're going to start by putting r equals 1 into that expression for the rule. So if we put in r equals 1, the first bracket becomes 1 plus 1 is 2, the second bracket becomes 1 plus 3 is 4, we then get minus 1 times 3. So we're not going to simplify that, we're just going to leave it as it is. Now we're going to put in r equals 2 for the next term. I'm going to add it because this is a summation. So we're going to say plus, and then the r equals 2 term will be 3 times 5, take away 2 times 4. Again, we're just going to add the next term on, the r equals 3 term, to see if we can see a pattern emerging. So the r equals 3 term added on will become 4 times 6, take away 3 times 5. You might be able to see some terms appearing more than once already. Now this would continue for a while, so what we're going to do is represent that by putting 3 dots. So 3 dots just means continue in this manner until we get to the last few terms. So given that the last term is going to be the nth term, the term before that will come from substituting in n minus 1, and the term before that will come from substituting in n minus 2. So we'll just do the last 3 terms with n minus 2, n minus 1 and n for the r values. So the n minus 2 term is going to simplify down to n minus 1, n plus 1, take away n minus 2 times n. Then the n minus 1 term, so the term before the last one, will become n times n plus 2, take away n minus 1 times n plus 1. And then finally the last term comes from putting in r equals n, which is n plus 1, n plus 3, take away n, n plus 2. So we're now just going to look and see if there are any terms that we can cancel out. So we can see at the top we've got a 2 times 4, but we've also got a minus 2 times 4 on the next line down. So that will be 8 take away 8, which will be 0. So those 2 terms there, they will cancel out. We can see that the 2 terms below those as well will cancel out because we've got a plus 3 times 5 and a minus 3 times 5. So again, that will become 0. Now we can see if we continued in this manner, the plus 4 times 6 would cancel out with the minus 4 times 6. That's just below as far as we've got. So that 4 times 6 will cancel with an unseen minus 4 times 6 on the line below. We can also see that if we continued in this diagonal arrangement, that the minus n minus 2 times n would also cancel with an unseen term on the line above. So that one will cancel out as well. We can then see that n minus 1 times n plus 1 will cancel with the negative of that below it. And similarly, the n plus 2 will cancel with the negative version of that. So the only 2 terms in this entire summation that have not cancelled is the minus 1 times 3 on the top row and the n plus 1, n plus 3 on the bottom row. So those 2 are left, leaving us just with n plus 1, n plus 3, take away 1 times 3, which is 3, which multiplies out and simplifies to n squared plus 4n. So we can say, using the method of differences, that the sum of the rule above, r plus 1, r plus 3, take away r, r plus 2, for the first n terms, is just n squared plus 4n. That can be simplified slightly to n plus 4. So as I said earlier, the method of differences is used for finding summations of particular types of sums of series. So there needs to be something looking a bit like this. The sum of, and then maybe a function of r plus 1 minus a function of r. So there needs to be a minus in the middle so that some positive terms will cancel with some negative terms, and the functions need to be similar to each other so that the cancelling occurs. It doesn't need to be exactly of this form, so you could have something like f of r plus 2 take away f of r. If that was the case, it would just take an extra line before the terms cancelled out. So if we had something in this form, then the only terms that wouldn't cancel out would be a minus f of 1 on the first line and an f of n plus 1 on the last line. So it would look something like this. And the method of differences can also be used to prove the standard summation formulas that we've been using earlier. So the sum of r, r squared, r cubed, and so on. So here is another example of a situation where we might use the method of differences. The question doesn't explicitly say that we're going to use the method of differences, but we can see that it will be applicable because we've got a minus in between the two terms in the rule, and we've also got two functions that are very similar, just with one number different each time. So we're trying to find the sum of 1 over r take away 1 over r plus 2. So you can think of this as being f of r take away f of r plus 2. Now they've also given us a hint that the answer is going to be expressed in the form n bracket an plus b over 2n plus 1 n plus 2. That is going to help us because when we get to the end we can look and see whether our answer matches that form, and if it's right we should be able to find the numbers a and b to make this correct. So we're going to start off by writing down the first few terms of the sequence. So we're going to start with r equals 1. We're going to simplify it slightly, but we're not going to simplify the fractions fully. So the r equals 1 term, the first term in this series, will become 1 over 1 take away 1 over 3. And we're not going to simplify any more than that because hopefully some of these terms are going to cancel. So the r plus 2 term then, if we put r equals 2 into that function, gives us a half minus a quarter. Notice that we're adding on each line because this is a summation. So the r equals 3 term will become plus a third minus a fifth. And we could keep going. You can do as many terms as you like to make sure you've definitely got the pattern. So the r equals 4 term, we've got plus a quarter minus a sixth. And we're then going to skip out some steps. We're going to put dot, 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 and we're just going to work out the last 3 terms. So the n minus 2, n minus 1 and n terms, and hopefully that will then give us enough to cancel. So after a bit of a gap, the n minus 2 term, I just put this onto a separate line just so that it fits on the slide. You don't need to go sideways to carry on, you can just keep going straight down. So the n minus 2 term in terms of algebra becomes 1 over n minus 2 take away 1 over n. The n minus 1 term gives us 1 over n minus 1 minus 1 over n plus 1. And finally, term n is 1 over n minus 1 over n plus 2. So as I said, the only reason we've gone sideways here to carry on is just to fit it onto the slide. You can just keep going straight down in a column. Right, let's have a look and see what cancels then. So because the difference between the functions was 2 this time, we had f of r take away f of r plus 2. We're going to need to skip an extra line before we can see the cancelling taking place. But we can see we've got minus a third on the top line and plus a third on the third line down. We've then got minus a quarter on the second line and plus a quarter on the fourth line. We can see that the minus a fifth would cancel with an unseen fifth further down, and we can also see that the minus a sixth would do the same. And then similarly, with the 1 over n minus 2 and the 1 over n minus 1, they would cancel with an unseen term in the lines above. And then finally, we've got minus 1 over n and plus 1 over n, they would cancel. So this time we're left with 4 terms that haven't cancelled. There's 4 terms rather than just 2 terms because we had an extra gap between the f of r and the f of r plus 2. So the answer that we've got here is just going to be the sum of those 4. So add up the 1 over 1, the 1 over 2, the minus 1 over n plus 1 and the minus 1 over n plus 2. So adding all of those together, we're going to need to get everything over a common denominator. So the common denominator is going to be 2 bracket n plus 1, n plus 2. So if we multiply accordingly to get everything over common denominators, simplify down like this. You might want to just check the algebra on this, make sure you're happy with adding those algebraic fractions together. Everything over one denominator, and it should cancel down into the form that we've been asked for, which is this. So I've got n bracket 3n plus 5 over 2, n plus 1, n plus 2. So just by comparing that to the original question, we can see that A is 3 and B is 5. Okay, so now complete exercise 11C on page 245. Then come back and there is an exam question on the next few slides to have a look at. So this is an example of an exam question using the method of differences. Take a minute to pause the slide, have a go at the question, then continue. There's also a mark scheme at the end if you want to check it. So the first part is just asking us to add together these algebraic fractions and find the value of A. So if we add these two fractions together, well, say subtract these two fractions, we're going to get them over a common denominator. So the common denominator is going to be 5r minus 2, 5r plus 3. So the first fraction has been multiplied on the denominator by 5r plus 3, so I'm going to multiply the top as well, 5r plus 3. The second fraction has been multiplied on the denominator by 5r minus 2, so multiply the numerator by 5r minus 2 as well. So we put these together. The common denominator is 5r minus 2, 5r plus 3. The numerator is going to become 5r plus 3. Careful with the minus for the second fraction, so we've got minus 5r and then minus minus 2, which is just plus 2. So that gives us 5r minus 2, 5r plus 3 on the denominator. The numerator, we've got 5r minus 5r's cancelled out, 3 plus 2 is 5. So the answer to part A is A equals 5. Okay, so in part B, we've been asked to use the method of differences to show that this summation can be simplified down to give the fraction on the right. We're going to use the answer to part A as well. So in part A, we found that if we added the two fractions together, we ended up with a 5 on the top of the fraction. You'll notice that that's the same fraction, except here we're being asked to find the sum with just a 1 on the numerator. So I'm going to start by finding sum from r equals 1 to n of that same fraction on the denominator. I'm going to start by finding the sum with a 5 on the numerator. The reason for that is that I can then use the two fractions from part A to help with this. We do need to remember though that we need to divide the answer by 5 at the end to reflect the fact that we've started with a 5 when we should have started with a 1. So because we put a 5 on the top instead of a 1, we can now use two fractions from part A, which is 1 over 5r minus 2, take away 1 over 5r plus 3. So I'm going to start by putting the first few r values in. So r equals 1. I'm going to put r equals 1 into here. Get 1 over 5 times 1, take away 2, so 1/3. Minus, and if I put 1 into the second part, I get 5 plus 3, which is an 1/8. I'm going to say plus, and then add on the r equals 2 term. So the r equals 2 term becomes 1 over 5 times 2 is 10, take away 2 is 8, take away 1 over 5 times 2 is 10, plus 3 is 13. So the r equals 3 term, got plus, so put 3 into the rule, we get 5 times 3 is 15, take away 2 is 13, take away, and then 1 over 5 times 3 is 15, plus 3 is 18. So you need to go as far as it takes for you to see where the pattern is, where the cancelling is going to happen. I can already see that the 8th and the minus an 8th and the 13th and minus a 13th is going to cancel. So I don't need to do any more terms after that, now that I've spotted the pattern. Now skip to the end. Again, it's up to you exactly how many terms you do at the end. If you can get away with just doing 2 terms and you can see the cancelling, that's fine. If you prefer to do 3 or 4 terms at the end, that's entirely up to you. So because I can see the cancelling pattern is going diagonally, skipping 1 row, I'm just going to put in the last 2 terms. So I'm going to put in n minus 1 and then n. So plus, so here I've got 1 over 5 times n minus 1 minus 2 minus 1 over 5 times n minus 1 plus 3. Then finally, the r equals n term is 1 over 5n minus 2 minus 1 over 5n plus 3. So we can now see which of these terms are going to cancel. So the minus an 8th and the plus an 8th, the minus a 13th, the plus a 13th, the minus an 18th is going to cancel with a term on the next line. Similarly, this term here is going to cancel with one above it. And then finally, we just need to check, do these 2 terms here cancel? They should do. So this term here becomes 1 over minus 1 over 5n minus 5 plus 3. So that's 5n minus 2. So actually those 2 terms are going to cancel as well. So the only terms that we are left with here are the third on the first line minus 1 over 5n plus 3 on the second line. So we now just need to check whether that can be written in the form given above. So I'm going to get everything over a common denominator. 3 times 5n plus 3. So the first fraction has got 5n plus 3 on top. And the second fraction, we've multiplied the top and the bottom by 3. So we end up with 5n on the top over 3, 5n plus 3 on the bottom. Now when we look at the question that we've been asked to show, that's not quite what we've been looking for. If you remember, that's because the summation we're calculating is actually 5 times larger than the one we've been asked for in the question, because we started with a 5 on the top when we need to start with a 1. So for the last part of this question, you would divide the answer by 5 and then explain why. So you'd put a sentence saying, because the sum that we have found was 5 times larger than the required sum, we need to divide this answer by 5, which would then give us the answer I've circled at the top, n over 5 bracket 5n plus 3. So that statement explaining why you were dividing by 5 is important, and that would usually get you the last reasoning mark on the question. So in the last part, we're being asked to consider the sum of that same series, but starting with r equals 1 and going up to infinity. So even though this series has got an infinite number of terms, because the terms that are being added on each time are getting smaller, this can still tend towards a finite limit when we add them all together. So in order to calculate this, we need to have a little bit of an understanding of how limits work. So we already know that the sum of the first n terms can be written as n over 3 bracket 5n plus 3. That was the answer from part B. So I'm just going to write this out as n over 15n plus 9. I'm going to use a little trick that's often used in limits, which is to divide the numerator and the denominator by n. So by doing that, the numerator becomes n over n, which is 1. The denominator, so 15n divided by n is just 15. And then the 9 divided by n, we're just going to leave it as 9 over n. So the reason we've written it like that is because it makes it easy to see what happens as n gets very large. So we're going to say as n tends to infinity, well, the 1 and the 15, they're not going to change because they don't involve n. But the 9 over n is going to get smaller and smaller and smaller. If you think about doing 9 over 1, 9 over 2, 9 over 3, And then as n gets larger, 9 over 10, 9 over 100, 9 over 1,000, all of those values are getting smaller and close to 0. So 9 over n we can say is tending towards 0. So that means that the entire sum must be tending towards 1 over 15 because the 9 over n term is becoming negligible. So we can say that the sum from r equals 1 to infinity of this series that we're looking at, 1 over 5r minus 2, 5r plus 3, we can say that that sum from r equals 1 to infinity actually equals 1 over 15, because that is the limit of the sum as we let n tend to infinity.